Thank you so much for having me. I'm down here in Tucson. I work with the USGS and I am a physical scientist, but in our biological science center. And I really appreciate Joey for you swapping spots for me. And I put a lot of words on here because when it's recorded or shared, it's always good to have other people, you know, be able to read your slides for later. So I'm going to talk a little bit about the riparian corridor in terms of its greenness and water use on the Navajo Nation. My colleagues here, Ibrahima and Armando and Kamel, are part of the very important People Lab, otherwise known as the Vegetation Index and Phenology Lab. And Matt Lertz is a postdoc with NSF out of Colorado. And then, let's see, it's not going to go. These are the words on the slide. This is in a nutshell. I don't really know how to move this around a lot, but I'll just tell you this talk is about riparian areas. And I'm glad that I kind of did get to go last after these great speakers, and especially everybody talking about sort of riparian ecosystems before me. These are also culturally important areas for the Navajo. We measured the greenness and the water use. We call this actual ET, and I'll talk about the acronyms throughout here. So this is going to be, when you see ETA, that's what we're talking about, is the water use of the riparian plants. And we're specifically talking about the Little Colorado River watershed and only the bit in Arizona and only the parts falling on the nation. And so, it's also in Utah, Colorado, and New Mexico. Here on the left, you can see these areas where we actually had somebody hand digitize the riparian shrubs, and then in dark green is the riparian trees. We did use a summer scene to look at aerial photography to really narrow down some of the mapping that happened for the riparian corridor. And then we used Landsat to look at changes over the last 7 or 8 years. And our future goal, and not what I'm going to talk about today, is actually discriminating the Tamarisk from the other riparian species. This is a published paper, and it's also being used in the Navajo's amended statement of claim to the Little Colorado River rights, water rights adjudication. But most of the data will be used for resource management. So real quick, we like to use Dr. Seuss to explain basic transpiration. And one thing you might not know is that ET is one of the key components in the hydrological cycle, which indicates resilience and resistance of vegetation, particularly under drought. But it's also the second largest term in the water budgets after precip. And of course, it'll be expected to increase with warming. And because of the relevance of ET to most plant species, and 80% of global terrestrial ET is then due to transpiration. So we're trying to quantify that term, and it's not the easiest term to quantify either on the ground or remotely, what we're doing with remote sensing. So you might have seen this. This is a John Bradford publication. He's in my group at USGS in biology, and has since moved to the Washington area, not physically, but is working with the Climate Science Center there. So, this area of the Navajo Nation is actually the center of warming and drought predictions, and soil moisture potential is changing over time as temperatures are also shown to increase, and precip is changing as well, especially with the monsoons in this Four Corners region. Boop. So I just want to say, we know that the Little Colorado and the Lower Colorado and most of the lower basin rivers, including the region we're studying, are dammed and diverted and altered, and we have all of these changes happening as we're seeing increasing number of days over 100 degrees. We see more diversions of surface water, changes to water deliveries, and groundwater is declining. We have more land clearing. Fire cycles are then changing, as well as Tamarisk beetle defoliation from Diarrhobda species of beetle, and monsoon in particular, but other precipitation patterns are changing over time. So one of the things that we do is we're looking at how intact plant communities in the riparian ecosystem utilize water and how the disturbance can alter this. And that's changing future ecosystem resilience of these incredibly important riparian systems. Measuring landscape greenness through vegetation indices from satellite data like Landsat is a key input to an equation I came up with to look at actual ET specifically in riparian corridors that was validated. So we use this also with agricultural plots. Potential ET is often used to tell you the maximum amount of water use in alfalfa fields. And then everything else is relative to that maximum water use. Well, we study ETA in uplands and other dryland biomes, such as rangelands. Here it is, shrublands, sagebush shrubs, even urban green spaces. I came up with something I named after myself because I just thought it would be funny, but I'm also kind of a narcissist. So we have the Nagler ETA method. All of these have been ground validated with leaf and flux measurements of soil moisture and other areas on the ground. And then we scaled that to river reach using these biophysical and radiometric measurements. And so knowing how much water the ecosystem uses is so critical to managers who want to retain water for the people, plants, and animals in the landscape. So I want to say that our study here, we did have somebody use this NAPE imagery to hand digitize. It did not capture what we needed. And then we came up with a method to look at capturing the riparian trees versus the shrubs for the tributaries, streams, and springs, or groundwater dependent ecosystems that were considered in this area. And we used this 2014 to 2020. This was the equation, what I call the Nagler ET equation from Landsat, where potential ET would be your maximum daily water use. And we used one of 3 or 4 different algorithms that include a lot of variables like temperature and precip for measuring that potential ET. Here we use Blaney-Criddle, and we actually, for this study on the Navajo, used our first time of gridded weather data at 1 kilometer and then 4 kilometer for PRISM to input here as ETO, which goes into my equation. All of this was ground validated. We also ground validated here on the Navajo Nation. This was actually on the New Mexico side in Shiprock, along the San Juan River. We had creosote and greasewood and saltbush, cottonwood and willow and salt cedar. Those are some of the species that you find here. The beetle comes in and defoliates part of the salt cedar, and it turns brown, but only for a portion of the summer phenology. And then it regrows, re-leafs out, and sometimes actually has a higher maximum greenness after this defoliation cycle. Basically, remote sensing methods can only produce accurate measures of ET, but they are limited by the ground measurements, which they are calibrated and validated. We also flew drones over here, over the same region. So going back, we divided the Navajo Nation into the west side and east side based on basically mountains, phenology patterns, this kind of thing. And so we have show our results for both shrubs and trees and east and west. And I'm going to try to go a little faster. The hand digitized method didn't capture most of the riparian species. I don't know what happened. It's a lot of area to cover by someone digitizing. Maybe we needed a better method. So we looked at a conservative method and a best approximation method and calculated 2 or 3 separate areas. This first mapped area was only 12,000 acres, but our conservative was 48,000 acres. And our best approximation was about 25,000 hectares. And we use this to calculate all these water variables, including consumptive water use. Here's the entire Navajo Nation would have been these scenes that are not green. We used only 6 scenes over sort of the Arizona portion. And then calculated for the entire region, including the Hopi Nation, potential ET. This would be your maximum water use for these years. We were able to then create with this algorithm maps of precipitation potential ET, and then actual ET, and the water deficit or the water difference. And we did this at two scales, what you can't see here because I don't know how to do anything. This is the 4-kilometer prism data. And if I toggle, you can see it's a little bit changed here because this is the 1-kilometer daymet. And so you get finer resolution here in your water deficit and your actual ET than what we see here with the 4-kilometer. So here, this is the daymet data, and you can see we divided shrubs up here on the top graph from riparian trees, and we're measuring potential ET, actual ET, precip, and water deficit, and how these things change. To put them all on one scale, it minimizes, it masks out some of the great variance that we see here. But what we see is that 2014 was a little bit out of sync with the years 2015 to 2019, which just showed increases in ET for the shrubs and the trees over time. And we did a standard anomaly. We showed that 2017 was about the same as our actual average of the full data set. So we know here that precip was a little odd in 2015, a little high and a little bit low in 2020. And that changed some of our results. And when we did it with Prism, we saw that same pattern that you see here. It's just that it was a lot coarser. And this is a lot to look at, but I put it here because people might pass these slides around later. The one on the left is our best approximate, I'll move it, estimate. And our one on the right is the conservative estimate. This is for the 1-kilometer data. And our total Navajo Nation consumptive use in this acre feet in the last column was very, very close between the two, 31,600 acre feet versus 37,000 acre feet. And so what we were looking at is that our two estimates fall nicely within the estimates that were previously done on the Navajo Nation in prior years. And I'll show you that last, but I just want to say here's a way of looking at that. From left is the daymet 1-kilometer and right is the 4-kilometer. And if you look at that same consumptive use, you're seeing about 37,000 acre feet with 1-kilometer resolution. And then for 4 kilometers, it's 41,005. So now we've got a nice range of data to show what we've done for shrubs on the west side, trees on the west side, a subtotal of both. For acre feet, we should have it for the east side. We have the combined area. And then we have that for the actual ET and then the potential ET. So it's about 7,000 acre feet for consumptive use. And these are all in different metrics because of the attorneys that are then using this to talk about millimeters versus inches or feet and acre feet. So that's why you have a lot of that. So I just want to highlight as we get to the end here that for the Navajo reservation, about 36,600 acre feet was the median for the 3 different areas that we produced with remote sensing. The best approximation was what we ended up using with daymet. The conservative estimate is reported, and then the change was 37,000 acre feet to about 41,500 acre feet during using different 1 or 4 kilometer resolutions of input data. We have a final estimate from our literature review that was not part of this Navajo Nation study. Prior to that, there was an estimate of 25,000 to 46,000 acre feet, and that's 36.9 was right in the middle of that. Well, so is the 41.5 by Prism, but the higher resolution is really what we're aiming for. The study on the Hopi Reservation showed that even with inside of the Navajo Nation sits the Hopi Reservation, and that was 39,700 acre feet. So again, falling within that. So these estimates refine what was previously done in these like 2005 and 2008 and literature estimates for academic literature. So our estimates kind of refine that range. And I just want to quickly say again.
Oh, just a couple minutes left.
Okay, yeah, we're going to wrap up. I just want to say up here that we've created a data explorer, and that allows once USGS publishes the data in a data release, and it's already published in a journal paper as well, people can go in with a password, it's password protected, and go in and actually create their areas of interest and create these graphs of greenness or water use and change maps over time. And this is sort of the platform architecture, the data processing flow from my colleague Pamela, who's biosystems engineering, and he's kind of head of the drone lab as well there. So this is the link for that. You can't really see anything at this point because the data has to be requested, and then I send you a password to get access to it. And the last thing I want to tell you is that one of the lit review papers that came out that's not related to the Navajo Nation per se is that we did like a water footprint. You've probably seen these at zoos or museums all over the place. Our colleague Arian Hoekstra, here he is, he's acknowledged here, came up with these water footprints for things like how much water does it take to make your coffee in the morning? Well, I decided to do that for the riparian vegetation. And we have here other riparian water use for velvet mesquite, Russian olive, honey mesquite, arrowweed, saccatone grass, giant reed, cottonwood. And I just wanted to say alfalfa, we put that there because that is our go-to potential maximum water use, which is very close to our reeds and other water users along the riparian corridors in the Southwest. So I just want to say this is also found online here, and it's an entire, 4 or 5, 6 page sort of fact sheet about how Tamarisk is changing, transforming our corridors in the Southwest. So we're very grateful to Fred Phillips Consulting and the Navajo Nation, of course, for bringing this work to the USGS, and it was published with these 4 different reviewers, USDA included, and ARROS out of USGS, and Nevada Water Science Center. And you can find that here, and we just want to say thank you very much for inviting us or inviting me to present this data.